Breakthrough Alzheimer's discovery reveals 5 distinctive variants. Scientists have identified 5 distinctive biological variants of Alzheimer's disease, which appear to differ in how they affect the brain and potentially how they respond to treatment. And as my grandfather died from, well, there was a debate whether it was dementia or Alzheimer's or both, so this is kind of... the international research team that analyzed several cerebrospinal fluid proteins in 606 people say this means that medications already tested may have falsely seemed to be ineffective or only slightly effective. The discoveries could lead to more personalized therapies or preventative measures for these subtypes. It also presents hope for early diagnosis and intervention to delay the onset of symptoms of Alzheimer's disease. Given the distinct patterns of molecular processes and AD genetic risk profiles, it is likely that AD subtypes will require specific treatments, writes neuroscientist Betty Dijems from the Alzheimer's Cancer Center in Amsterdam and colleagues. Alzheimer's disease, a neurodegenerative disorder that affects millions of people worldwide, is characterized by the buildup of amyloid and I don't remember how they say it. Tau proteins in the brain, leading to progressive memory loss and cognitive decline. In addition to the buildup of amyloid and tau proteins forming clumps and tangles inside the brain tissue, we know other biological processes and other tissues are involved. Using updated technology, researchers were able to accurately measure critical components of these other processes. Dijems and her team used mass spectrometry proteomics to analyze cerebral spinal fluid from 419 people with Alzheimer's and 187 controls, looking for differences in protein levels. This led to the selection of 1,000 Alzheimer's related proteins for analyzing. The researchers were able to identify 5 distinct biological subtypes of the disease, distinguishing by the variations such as hyperplasticity. I can't say the others, but I can say that apparently. Immune activation, RNA dysregulation, chloroid plexus dysfunction, and blood-brain barrier impairment. Each variation was characterized by specific alterations in clusters of proteins related to inflammation, nerve cell growth, and other biological processes. 3 subtypes recapitulated our previously identified 3 subtypes: hyperplasticity, innate immune activation, and blood-brain barrier dysfunction. We further identified 2 additional AD subtypes, one with RNA dysregulation and one with chloroid plexus dysfunction. Identifying each variant's biomarkers may help us diagnose Alzheimer's earlier when intervention is most effective. Researchers also looked at magnetic resonance imaging, MRI, scans from a subset of 503 participants to compare subtypes to individual volume differences in certain brain regions. Subtypes have a distinctive AD genetic risk profiles, the team writes, adding that they also differ in clinical outcomes, survival times, and anatomical patterns of the brain atrophy. Hyperplasticity seems to involve an overactive cellular growth response, leading to amyloid and tau protein buildup. An innate immune activation. The immune system goes into overdrive, excessively attacking healthy brain tissue. The RNA dysregulation involves changing in the transportation of proteins along axons that allow nerve cells to function correctly. Chloroid plexus dysfunction impacts the ventricular system of the brain, which contributes to the cerebral spinal fluid production and transfer of nutrients to the brain. Blood-brain barrier impairment weakens the barrier protecting the brain, allowing damaging molecules to infiltrate. Kind of what happened with me with my injury. Unlike hyperplasticity, this type of feature slow nerve cell growth and low amyloid production. This could mean that some drugs only work in one Alzheimer's type. Amyloid-focused medicine, for instance, may treat a subtype with increased amyloid production, but could potentially harm a subset with the decreased production. Side effects arising from certain treatments may also depend on subtype, the authors say. For example, while antibiotics may more easily cross the blood-brain barrier in subtype 5, these individuals may be at increased risk for cerebral bleeding, which can occur with antibody treatment. Traditionally, Alzheimer's has been viewed as a single disease with some variations in symptoms and progression. Despite extensive research, there is no cure, and current treatments only offer limited symptom management. More studies are needed to validate these new findings and investigate whether variants do respond differently to medicines. That said, it is an exciting step towards forward in the ongoing fight against Alzheimer's, and each discovery like this brings us one more closer to finding a cure. All right, 2 more articles. Woo! Do we have quantum brains? Irrational behavior follows strange rules. Human behavior is an enigma that fascinates many scientists, and there has been much discussion over the role of probability in explaining how our minds work. This article is going to play into the next article, which I'm going to read, which is kind of an interesting thing. That's why I figured I was going to do this one first and then the other one. Probability is a mathematical framework designed to tell us how likely an event is to occur and works well for many everyday situations. For example, it describes how the outcome of a coin toss, as in half or 50%, because throwing heads or tails is equally probable. Probable. Yet research has shown that human behavior can't be fully captured by these traditional or classic laws of probability. Could it instead be explained by the way probability works in the more mysterious world of quantum mechanics? Mathematical probability is also a vital component of quantum mechanics, the branch of physics that describes how nature behaves at the scale of atoms or subatomic particles. However, as we'll see, the quantum world probabilities follow very different rules. Discoveries over the last 2 decades have shed light on the crucial role for quantumness in human cognition, how the human brain processes information to acquire knowledge or understanding. These findings also have the potential implications for the development of artificial intelligence. Is that the same guy? Nope. Sorry, I was having a moment. Nobel laureate Daniel Kahneman and other cognitive scientists have carried out work on what they describe as the irrationality of human behavior. When behavior patterns do not strictly follow the rules of classical probability theory from a mathematical perspective, they are deemed irrational. For example, a study found that a majority of students who passed an end-of-term exam favor going on holidays afterwards. Likewise, a majority of those who failed also wanted to go for a holiday. If a student doesn't know their result, the classical probability would predict they would opt for the holiday because that is the preferred option whether they have passed or failed. Yet, in the experiment, a majority of students preferred not to go on holiday if they didn't know how they did. Intuitively, it's not hard to understand that students might not want to go on holiday if they're going to be worrying about their exam results the whole time. But classical probability does not accurately capture the behavior, so it is described as an irrational. Many similar violations of classical probability rules have been observed in cognitive science. Quantum brain? Question mark. In classical probability, when a sequence of questions is asked, then the answers do not depend on the order in which the questions are posed. By contrast, in quantum physics, the answers to a series of questions can depend crucially on the order on which they are asked. For one example is the measurement of the spin of an electron in two different directions. If you first measure the spin in the horizontal direction and then the vertical direction, you will get one outcome. The outcomes will generally be different when the order is reversed because of a well-known feature of quantum mechanics. And I know this one is one of those, the case of observing. Simply measuring a property of a quantum system can affect the thing that's being measured, in this case, the electron spin, and hence the outcome of any subsequent experiments. I guess the other thing that just occurred to me is the human irrationality thing. That might be a good example is Schrodinger's cat, of whether the cat's alive or dead, we don't know. Kind of idea, but this has to do with actual, not quantum, but I mean human behavior, but it's still quantum, but Okay, simply measuring a property of a quantum system can affect the thing that's being measured, in this case an electron spin, and hence the outcome of any subsequent experiments. The other thing is whether electrons are a wave or a... When they did the... I'm gonna have to pull it up. Yeah. Wave theory? Yeah, wave particle duality. Let me just read the 10 so I don't go into the whole thing. Wave particle duality is a concept in quantum mechanics that quantum entities exhibit particle or wave properties according to the experimental circumstances. It expresses an inability of the classical concepts, such as a particle or a wave, to fully describe the behavior of quantum objects. During the 19th and early 20th century, light was found to behave as a wave, and then later discovered to have a particulate character, whereas electrons were found to act as particles, and then later discovered to have wave-like aspects. The concept of duality arose to name these contradictions. That's what I'm talking about when I mention that. Outcomes will generally be different when the order is... okay. I've read that. Order dependence can also be seen in human behavior. For example, in a study published 20 years ago about the effects that a question order has on a respondent answers, subjects were asked whether they thought the previous US President Bill Clinton was honest. They were then asked if his Vice President Al Gore seemed honest. Well, there's also the wording of seem or was honest. When the questions were delivered in this order, a respective 50% and 60% of respondents answered that they were honest. But when the researchers were asked respondents about Gore first and then Clinton, A respective 68% and 60% responded that they were honest. On an everyday level, it might seem that human behavior is not consistent because it often violates the rules of classical probability theory. However, this behavior does appear to fit with the way probability works in quantum mechanics. Observations of this kind have led cognitive scientists Jerome Bosmeyer and many others to recognize that quantum mechanics can, on a whole, explain human behavior in a more consistent way. Based on this astonishing hypothesis, a new research field called quantum cognition has arisen within the area of cognitive sciences. How is it possible that thought processes are dictated by quantum rules? Is our brain working like a quantum computer? Blech. Quantum computer? No one knows the answers, but empirical data strongly appears to suggest that our thoughts follow quantum rules. What's up, Haru? No, they're going into... basically, what they're doing, by the looks of it, is a lead-in for people who... I'll say... lead-in to get people more interested in it, so that people don't feel like they're jumping into a pond without understanding it. Well, at least sticking a toe into a pond to make sure it's not as deep. Where sometimes, you know, when I pulled up one of those articles before that was just the research paper, and me staring at it and going, yeah, no, why did I open this again? Was the information, there's a lot of information there, but I felt like I was over my depth with it. And so what it's doing is slowly leading me to the pool this way, the way this article was set up by the looks of it, so that I can understand this part. So let me keep reading to see if I can, by following the logic you've shown me before. You're leading me into this kind of thing. That's how the article is set up by the looks of it, if you understand that. Dynamic behavior. In parallel to these exciting developments, over the past 2 decades, my collaborators and I have developed a framework for modeling or simulating the dynamics of people's cognitive behavior as they digest noisy, that is, imperfect information from the outside world. We again found that mathematical techniques developed for modeling the quantum world can be applied to modeling how human brain processes noisy data. These principles can be applied to other behavior biologies beyond just the brain. Green plants, for example, have the remarkable ability to extract and analyze chemicals and other information from their environment and to adapt to changes. Which, we could pull up that. Oh, it's a conversation, so it's more of a giving examples of what... You know how you postulate ideas to each other? I think this is, now that I'm, the kind of bottom part is, it's a scientist postulating to other scientists to see where they would stand on it and whether they want to research it further kind of thing. My rough estimate based on a recent experiment on common bean plants suggests that they could process this external information more efficiently than the best computer we have today. In this context, efficiency means that the plant is consistently able to reduce uncertainty about its external environment to the greatest extent possible in its circumstances. This could, for example, encompass easily detecting the direction that light is coming from so the plant can grow towards it. The efficient processing of information by an organism is also linked to saving energy, which is important to survival. Similar rules may apply to the human brain, particularly to how our state of mind changes when detecting outside signals. All of this is important for the current trajectory of technological development. If our behavior is best described by the way probability works in quantum mechanics, then to accurately replicate human behavior in machines, AI systems should follow quantum rules, not classical ones. I've called this idea artificial quantum intelligence. A great deal of research needs to develop practical applications from such an idea. Yeah, the whole thing about the question of the answers in order, I guess, now that I think about it, since you were pointing that out, this feels like they were trying to be you know how everybody talks about the duality, even though I messed up the name of it, the duality of light particles and being both a wave, well, duality of light being both a wave and a particle kind of thing. And they felt like pulling out this instead to make it sound like, oh, I've researched something deeper, but it doesn't completely fit it correctly. Or it doesn't give the depth it needs to. How can I put it? It's trying to be hipster. Well, why did I find something that nobody else has heard of? I mean, the better one was the whole thing of the study found that the majority of students, the study itself actually felt more like this area, the human irrationality area, felt more like a good example of it than the other, if you understand what I mean by that. This one about students didn't know the result. Classical probability would predict they'd opt for the holiday because it was a preferred option, whether they passed or failed. That one feels like it fits more, yeah. Alright, now to the final one. Scientists, after decades of study, concludes we don't have free will. This also is a postulation, so it's not like he concludes, it's not accepted kind of thing, but it's an interesting read. That's the reason why I was bringing this up. Before epilepsy was understood to be a neurological condition, people believed it was caused by the moon or by phlegm in the brain. They condemned seizures as evidence of witchcraft or demonic possessions and killed or castrated sufferers to prevent them from passing tainted blood onto the next generation. Today, we know epilepsy is a disease. By and large, it's accepted that a person who causes a fatal traffic accident while in the grip of a seizure should not be charged with murder. I repeat, I'm not saying I agree completely with this article. I just think it's an interesting head scratcher. I'm gonna say this now. It's a discussion-worthy thing. That's good, says Stanford University neurobiologist Robert Sapolsky. That's progress, but there's still a long way to go. After more than 40 years studying humans and other primates, Sapolsky has reached the conclusion that virtually all human behavior is as far beyond our conscious control as convulsions of a seizure, the division of cells, or the beating of our hearts. This means accepting that a man who shoots into a crowd has no more control over his fate than victims who happen to be at the wrong place at the wrong time. It means treating drunk drivers who barrel into pedestrians just like drivers who suffer a sudden heart attack and veer out of their lane. The world is really screwed up, and made much more unfair by the fact that we reward people and punish people for things they have no control over. We've got no free will. Stop attributing this stuff to us that isn't there. Slavovsky, a MacArthur Genius Grant winner, is extremely aware that this is an out there position. Most neuroscientists believe that humans have at least some degree of free will. So do most philosophers and the vast majority of the general population. Free will is essential to how we see ourselves, fueling the satisfaction of achievement or the shame of failing to do the right thing. Saying people have no free will is a great way to start an argument. This is partially why Slavovsky, who describes himself as a majorly adverse to interpersonal conflict, put off writing his new book, Determined, a science of life without free will. Slavovsky, 66, has a mild demeanor and a Jerry Garcia beard. For more than 3 decades, he escaped the politics of academia to study baboons in the rural Kenya for a few months every year. I'm really not trying to sound like a combative jerk in the book. He said, I deal with human complexities by going and living in a tent. So yeah, I'm not up for a lot of brawls about this. Analyzing human behavior through the lens of any single discipline leaves room for the possibility that people choose their actions, he says. But after a long cross-disciplinary career, he feels that it's intellectually dishonest to write anything other than what he sees as the unavoidable conclusion. Myth is a free will, and the sooner we accept that, the more just our society will be. Determined, which comes out, this was a while. I think October, yeah. Yeah, I've been sitting on this one, because I wasn't sure when I wanted to put it, because I wanted to have, have a good juxtaposition with it. Determined, which comes out today, builds on Slavovsky's 2017 bestseller, Behave, The Biology of Humans at our Best and Worst, which won the Los Angeles Times Book Prize, and a slew of other accolades. The book breaks down the neurochemical influences that contribute to a human's behavior, analyzing the milliseconds to century proceedings, saying the pulling of milliseconds to centuries proceedings, saying the pulling of a trigger or the suggestive touch on an arm. Determined goes a step further. If it's impossible for any single neuron or any single brain to act without influence from other factors beyond its control, Slavovsky argues, there can be no logical room for free will. Many people with even a passing familiarity with human biology can comfortably agree with this up to a point. We know we make worse decisions when hungry, stressed, or scared. We know our physical makeup is influenced by the genes inherited by distant ancestors and by our mother's health during her pregnancies. Abundant evidence indicates that people who grew up in homes marked by chaos and deprivation will perceive the world differently and make different choices than people raised in safe, stable, resource environments. A lot of things are beyond our control. But like everything, we have no meaningful command over our choices, careers, romantic partners, or weekend plans. If you reach out right now and pick up a pen, was even that as insignificant action somehow preordained? Yes, Slavovsky says, both in the book and into the countless students who have asked the same questions during his office hours. What the student experiences as a decision to grab the pencil is preceded by a jumble of competing impulses beyond his or her conscious control. Maybe their peak is heightened because they skip lunch. Maybe they're subconsciously triggered by the professor's resemblance to an irritating relative. Then look at the forces that brought them to the professor's office, feeling empowered to challenge a point. They're more likely to have had parents who themselves were college educated, more likely to hail from an individualistic culture rather than a collective one. All those influences subtly nudge behavior in predictable ways. You may have the uncanny experience of talking about an upcoming camping trip with a friend, only to find yourself served with ads for temps on social media later. Your phone didn't record your conversation, even if that's what it feels like. It's just that collective records of your likes, clicks, searches, and shares paint such a detailed picture of your preferences and decision-making patterns that algorithms can predict, often with unsettling accuracy, on what you're going to do. Something similar happens when you reach for that pin, Slavovsky says. So many factors beyond your conscious awareness brought you to that pin that it's hard to say how much you chose to pick it up in the first place. Slavovsky was raised in I don't know why this has anything to do with it, but I mean, raised in Orthodox Jewish household in Brooklyn, a son of immigrants from the former Soviet Union. Biology called to him early. By grade school, he was writing fan letters to primatologists and lingering in front of the taxidermied gorillas at the American Museum of Natural History. But religion shaped... Oh, okay, now I see where it's coming from. Religion shaped life at home. All that changed in a single night in his early teens, he says, while grappling with the questions of faith and identity. He was struck by an epiphany that kept him awake until dawn and reshaped his future. God is not real, there is no free will, and we primates are pretty much on our own. Kind of a scary thing to wake up to. Suddenly. That was a kind of big day, he said with a chuckle. And it's been tumultuous ever since. Skeptics could seize on this to rebut his arguments. If we aren't free to choose our actions or beliefs, how does a boy from a deeply religious conservative home become a self-professed liberal atheist? Change is always possible, he argues, but it comes from external stimuli. Sea slugs can learn to reflexively retreat from an electrical shock. Through the same biochemical pathways, humans can change by exposed to external events in ways we rarely see coming. Imagine he offers a group of friends that go see a biopic about an inspiring activist. One applies the next day to join the Peace Corps. One is struck by the beautiful cinematography and signs up for a filmmaking course, and the rest are annoyed they didn't see a Marvel film. All the friends were primed to respond as they did when they sat down to watch. Maybe one had a heightened adrenaline from a close call from another car on the drive over. Maybe one was in a new relationship and awash with oxytocin, the so-called love hormone. They had different levels of dopamine and serotonin in their brains, different cultural backgrounds, different sensitivities to sensory distractions in the theater. None chose how the stimulus of the movie would affect them any more than the sea slug decided to wince in response to a jolt. For fellow adherents of determinism, the belief that it's impossible for a person to, in any situation, act differently than they did, Slavovsky's scientific defense of the cause is welcome. Who we are and what we do is ultimately the result of factors beyond our control, and because of this, we are never morally responsible for our activities in the same sense that would make us truly deserving of praise and blame, punishment and reward. Greg Corsoro, a philosopher at SUNY Corning, who read the first drafts of the book. I'm in agreement with Slavovsky that life without belief in free will is not only possible but preferable. Karos is co-director of the Justice Without Retribution Network, which advocates for an approach to criminal activity that prioritizes preventing future harm rather than assigning blame, focusing on the cause of the violent or antisocial behavior instead of fulfilling a desire for punishment. He said that will allow us to adopt a more humane and effective practices and policies. Like I said, I repeat, this is a talking point. I don't completely agree with this, but it's also really interesting to see. Theirs is a very much a minority viewpoint. Volsky is a wonderful explainer of complex phenomena. Peter U. Tays, a Dartmouth neuroscientist and author of the 2013 book, The Neural Basis of Free Will. However, a person can be both brilliant and utterly wrong. See, so this is somebody, you know, bringing a counterpoint. Neural activity is highly variable, Tissy says, with identical inputs often resulting in non-identical responses in individuals and populations. In other words, the article I was reading earlier about the quantum brain. See how I connected it? It's more accurate to think of those inputs as imposing parameters rather than determine specific outcomes. Even if the range of potential outcomes is limited, there's simply too much variability at play to think our behavior is predetermined. What's more, he said, it's harmful to do so. Those who push the idea that we are nothing but deterministic biochemical puppets are responsible for enhancing the psychological suffering and hopelessness in the world. Even those who believe biological limits our choices are wary of how openly we should embrace that. Saul Smolsky, a philosopher at the University of Haifa in Israel and author of the book Free Will and Illusion, rejects the idea that we can will ourselves into transcend all genetic and environmental constraints. But if we want to live in a just society, we have to believe that we can. Losing all belief in free will and moral responsibility will likely be catastrophic, he said, and encouraging people to do so is dangerous and even irresponsible. A widely cited 2008 study found that people who read passages dismissing the idea of free will were more likely to cheat on a subsequent test. That sounds like a stupid thing to read. That doesn't... You know, correlation, causation kind of thing. That feels like that doesn't... Other studies have found that people who feel less control over their actions care less about making mistakes in their work, and that disbelief in free will leads to more aggression and less helpfulness. Well, how did you put out... Okay. Sometimes wording something can really affect in surveys. That's the reason why there's an entire study of trying to basically when you're doing a polling work, well, not science, but yeah, it is a science now that I think about it. There's an entire thing to keep, you know, polling questions to be as non-biased as possible and using neutral terms in the sense of, you know, if you say something like disastrous, you know it's something wrong. Disastrous can't be something good. Like those types of words, what I mean by neutral words. Within asking someone a question where you've kind of already slated up the answer on how the question is. If you want a masterclass in seeing an interview and an interviewee with that is actually don't, now that I think about it, because that would be putting support to that documentary, which can go suck a lemon, which is the Casey Anthony documentary, which has her however many years later, you know, continuously lying about, you know, killing her daughter. How the questions were basically absolutely lined up for her. Where 90% of the answers were in the question itself. So when you say often when you say polls and all this other stuff, you should always ask how it was, how the questions were asked, because there's a certain amount of problems with that. So what I'm talking about is the 2008 study. That's why the passages dismissing the ideal of free will. How did they put? What was their description of free will? How did they put it out there? And correlation, causation thing. Zabowski discusses such concerns in his book, ultimately concluding that the effects seen in such experiments are too small and their lack of reproducibility too great to support the idea that civilization will crumble if we think we can't control our fates. See? That, like I said, I'm not completely agreeing with it, but I'm not... It's just an interesting thing to think about. The more compelling critique, he says, is the eloquently articulated in a short story, What's Expected of Us. A speculative fiction writer, Ted Chiang, the narrator describes a new technology that convinces users their choices are predetermined, a discovery that saps them of their will to live. It's essential that you behave as if your decisions matter, the narrator warns, even though you know that they don't. The greatest risk of abandoning free will, Sapolsky concedes, is that we'll want to do bad things. It's that without a sense of personal agency, we won't want to do anything. Yeah, this is the last article when I finish it, but... Night, hun! It's dangerous to tell people we don't have free will. The mass majority of the time, I think it's a hell of a lot more humane. Yeah, the thing is, the greatest risk of... one of the arguments that people say about atheism and all this other stuff is if... I know this isn't free will, but is the idea that if you have no like God or belief of retribution for your actions, you'll still do bad things. That means that atheists are less moral people than non-atheists. But say that's just implying that morality is only religious based. Yeah, it's implying that morality is just religious based rather than looking at a fellow human and going, I see you. Yeah. Like, Zalowski says he won't persuade most of his readers. It's hard to convince people who have been harmed that perpetrators deserve less blame because of their history of poverty. It's even harder to convince well-off that their accomplishments deserve less praise because of their history of privilege. If you have time to be bummed out by that, you're one of the lucky ones. His true hope, he says, is to increase compassion. Maybe if people understand how thoroughly an early history of trauma can rewrite a brain, they'll stop lusting for harsher punishments. Maybe if someone realizes they have a brain condition like depression or ADHD, they'll stop hating themselves for struggling with tasks that seem easier to others. Just as previous generations thought seizures were brought by witchcraft, some of our current beliefs about personal responsibility may eventually be undone by scientific discovery. We are machines, Sapolsky argues, exceptional in our ability to perceive our own experience and emotions about them. It is pointless to hate a machine for its failures. There is one last threat he can't resolve. It's logical, indefensive, ludicrous, and meaningless to believe that something good can happen to a machine, he writes. Nonetheless, I am certain that it is good if people feel less pain and more happiness. But yeah, that was the final article. It was just one of those things of a head scratch to think about as we end this stream kind of thing, because it was just, didn't completely agree with it, but it was just, well, some of these, this is one of those, just because I read it loud does not mean I agree with or disagree with some of this stuff. I'm just, it's an interesting to think about. All right. Let's see who's coming. Let's go annoy Pando, just cause Pando. Night, Haru, thank you for staying. Did you just get in here or are you just listening? Welcome, Half Scott. Appreciate. Okay.
Job.
Alright, y'all, this was Ishnai Ciarfox. I hope you have a good day or night. Well, it's good that you were able to at least say hi at least before I left. Back and forth, back and forth. Well, your job probably wouldn't let you sit too much. Alright, y'all, this was Ishnai Ciarfox. I hope you have a good day or night, whenever it is, wherever it is you currently are. If you're watching this on YouTube, please like, subscribe, and comment. Remember, this is only every first Thursday of every month.